We're looking at day 2 of 2-2. So we're going to do some more story problems. Couple of different types of story problems today, and I'm going to do kind of similar to what I did on Friday. I'm going to do a couple of problems with you from like the homework set, and then I'm going to assign some that are going to be very similar to those as well. So to start off with, we're on page 73, I believe. And the first one I'm going to look at with you is, and I'm going to go, remind me that I'm going to go over number 11 with you today from Friday's homework. I think I told you on Friday I would go through that one with you because that one's a little bit tricky, I think. But what we're going to do here is we're going to do number 25 together. All right, so we got a couple of these. These are what we call consecutive integer problems. You might have seen these or remember these, maybe going back to Algebra 1, or we had some similar to this, like maybe even in geometry where we talk about consecutive integers for different things. So what it says on this one, sum of two consecutive integers is 191. So we know that sum means we're adding. When I say two consecutive integers, what would be an example of like two consecutive integers? There's a ton of them. What's an integer, first of all? We've talked about integers earlier in chapter 1. What type of number is an integer? Can we have a decimal? Nope, no decimals. Can we have a fraction? No. Can we have a negative? Possibly, okay. Probably not in this case because that has to add up to be 191. And when we say consecutive, what's that mean? Not necessarily the same. If I said Tuesday and Wednesday are consecutive days of the week, right? That means they're back to back, right next to each other, okay? Friday and Saturday are consecutive days of the week, okay? January and February are consecutive months because there's one right after the other. So consecutive means right next to each other or the next one. So when we talk about consecutive integers, we're talking about numbers like 4 and 5, 10 and 11, 20 and 21, right? And you could probably do this one by kind of guessing and checking because I'm looking for two numbers that are consecutive next to each other that eventually would add up to be 191. But what I'm going to do is I'm going to show you how you can come up with this algebraically, okay? And then we know we got the answer when we get done. So I'm going to say n is the first number, okay, or the first integer. If I said 7 was my first integer, what would be the next integer after 7? 8, right? What do we have to do to get from one integer to the next one? 14, 15, 24, and 25. What do we have to do in every situation to get from one to the next? Just add 1. So to get to the next integer, we're just going to add 1 to whatever n is. Okay. Those are my two integers. Back to back. Okay. Now, it says we're going to find the sum of those two to make 191. Okay, so now we're going to put these two together. We're going to say the first one is n. Second one is n plus 1. We're going to add those two integers together. and set it equal to 191. Kind of like on Friday. The hardest part here is setting up our equation. Okay, once we have the equation set up, then we should be able to solve it. I don't think that's necessarily going to be the hard part here, even though there's still mistakes that could be made. Getting the equation set up is the most important part. Combine like terms. We have n plus n here. So n plus n would become 2n. And then we're going to subtract 1 from both sides. And then we're going to divide by 2. So 190 divided by 2 gives us what? Did you guys get any sleep over the weekend? Holy smokes, you guys are dead today, man. Like a bunch of zombies looking at me out here. What do we get? 95? Okay, so that is my first number. Okay, 95. What would be the next integer after 95? Just add 1 to it, 96. Okay? And the way we could check it is if I added those two together, they better add up to be 191, which they do. So 95 and 96 are the two integers that we're looking for. Okay, second one, we're looking at the next odd problem, number 27. Okay, this one is very similar. The sum of 3 consecutive even integers is 78. So a couple of things different here. First of all, is we have even, and we have 3 of them. Okay, so we talked about consecutive integers would be like 4 and 5. What would be consecutive even integers? 4, 6, and 8. Good. That would be 3 consecutive integers, 4, 6, and 8, right? 4 consecutive even integers, I should say. We're looking at 3 even numbers in a row. 10, 12, and 14. Good work. Okay. Once again, you could probably kind of guess and check and get there eventually, but we're going to set up an equation so that when we get there, we have the answer and kind of have a way to get there. Okay. So my first step is going to be kind of like what we did on the last one. N is the first integer, whatever that is. Well, what do I have to do to get from one even number to the next even number? You got to add 2, right? When it was just consecutive, all we had to do was add 1. Here, I got to add 2. So that gets me to my second integer. But we're looking at 3 consecutive integers here. So what would I have to do to get to the third? We're going to add 2 more, right? So we would really have to add 4 to the original number. Like if I did 6, 8, and 10, if I start at 6 as my first number, I add 2 to get to 8, I add 4 to 6 to get to 10. So we add 4 to the original number, and that would be our third integer. Okay, and then once again, those 3, the sum of those 3, adds up to be 78. Hardest part is setting up the equation. If we have the equation set up correctly, now all we got to do is solve it. Okay, so we're going to combine like terms. N plus n plus n would become 3n. 2 plus 4 will become 6. Now it's just a two-step equation to solve. Subtract 6 from both sides. Divide by 3. So going back up here, 24 is the first even. My next even would be 26. And my third even would be 28. 3 consecutive evens, 24, 26, 28. If we add these 3 together, they better add up to be 78. So we've satisfied both conditions. 3 consecutive integers, even integers, and they have to have a sum of 78. Okay, so we call those consecutive integer problems. If you had a consecutive odd integer, it would be set up very, very similar to the even integer because all odds are going to skip a number. It's going to go every 2 or add 2 each time. So if you ever see the word odd, it will be set up very similar. Like number 28 says 3 consecutive odd integers, but don't let that throw you off. It would still be very similar to the consecutive even integers. Okay, the next one. Still on the same page, number 29. 2 angles are complementary. So we kind of got to go back and dig into our geometry days a little bit here. If 2 angles are complementary, anybody remember what the word complementary tells me? Add up to how much? Yeah, perfect. Okay. Complementary means 2 angles that equal 90. The other one, you might see this one pop up too, because it kind of goes hand in hand. We don't have this one on this problem, but 2 angles supplementary would be 2 angles that equal 180. Okay, so complementary, supplementary, if you look at some of those, you might see the word supplementary sometimes too. Okay, but on 29, we're just focused on complementary. We have 2 angles. We don't know anything about the first angle, so we're just going to say x is the first angle. The variable that you use here doesn't matter, guys. Okay, you can use whatever variable you want to use. If you want to use n, if you want to use x, if you want to use a for angle, go for it. Okay, don't get caught up on the letter that you're using necessarily. Okay, and then it gives me a statement. It says one angle is 15 more than twice the other angle. So if I said x is my original angle, the other angle is 15 more than twice the original. So what would be an expression that would represent the second angle? How would we write that? $15 more than twice an angle. Okay. How would you say? Close. 2x plus 15. Yep. Because we have that twice word in there also. Okay. 15 more than twice the other angle. Okay. This satisfies the twice, and then 15 more than that. Those are my 2 angles. Okay. And what we set up here was complementary means 2 angles that add up to equal 90. So I have an expression for both of those angles. Okay. So we're going to go x plus 2x plus 15 equals 90. Once again, once I have the 2 variables or the 2 expressions kind of stated, now we're just going to use those to write an equation out. Kind of very similar to what we did with the consecutive problems. And then from here, you just got to solve that equation out. X and 2x makes 3x. Subtract 15. And then divide by 3. Okay, the first angle is 25. On the consecutive problems, all we had to do was add something to it to get there. On this one, what do we have to do to find the second angle? Plug it back in. Yeah. So 25 is going to come over here. So 2 times 25 would be 50. 50 plus 15 would be 65. Okay. So that one is 15 more than twice the original. And then what should happen with these two angles? They also should add up to be 90, right? And that's how you can check your answer at the end. So kind of like we've talked about, whenever we have an equation, we should always be able to check these answers, right? And off the test last week, I could tell in some of the situations we didn't check our answer because the answer didn't work. The answer that we got didn't necessarily solve the equation or make it work. So if you have the opportunity or the ability to check, then check your answers, right? See if it works. See if it satisfies everything that we're talking about. Okay. Next one's going to be on the next page. Actually, 2 pages. It's on page 75. Okay. We're skipping over all those mixture and distance, rate, and time problems because those are I think another level up, and we're not going to worry about those right now. Okay. I'm just trying to keep it to some basic story problems where we get some practice writing out an equation, but not where we have to kind of manipulate and do other things with it. Okay, so the one we're going to do here is number 45. And we've got this big old situation given to us. We got this girl that ordered 16 iMac computers and 6 MacBooks. So 16 iMac and 6 MacBook. Total cost is $29,978. We don't know the cost of each one. So that's going to be our goal here is how much did each computer cost us to buy? Well, it tells us that the MacBook Pros cost $600 more than the iMacs. How much did each computer cost? All right, so the MacBook Pros cost $600 more than the iMacs. So I'm going to say X is the iMac's cost. How much does it cost for an iMac? We don't know what it is, so we're just going to use X. That's one of our goals to find. What would be an expression for the MacBook Pros? X plus 600. Good. Whatever that is, it's 600 more than that. Okay, so the MacBook's cost is X plus 600. Okay, now we're going to use all this information that we had here to figure out the cost of each one. If I buy 16 iMacs, and we don't know the cost of it, the cost is just X, we're going to take 16 times what the cost is. We just don't know what that cost is. It's just X. Okay, then we're going to do the same thing for the MacBooks. How many MacBooks did we buy? About 6 of them. And the cost would be X plus 600. And that equals the total amount of money that we spent. Okay. Say it over and over again. The hardest part is getting the equation set up. So you got to be really, really careful about setting up that equation. Because if I screw this up right here, it doesn't really matter what I do from here on out, right? Because now I'm solving an equation that's not even true. So you gotta be really careful about setting this up. Once I have this set up, then it kind of goes back to the things that we talked about in chapter 1 where we're solving equations. What's gonna be my first step here? Even before we do that, we got parentheses, right? And we're taking 6 times this whole thing. So we're gonna have to take 6 and distribute it. That's why the parentheses are really, really important in that case. Okay. And then we can combine like terms. $22x plus 3,600 equals 29,978. And now we're basically to a two-step equation again. Okay, so my next step would be, let's subtract 3,600. 29,978 minus 3,600, and then divide by 22. Okay, let's see what we get. Did anybody punch that in yet? Okay, and then divide by 22. Okay. So that would be the cost of the iMac. $11.99. Okay, and then to get the MacBook Pro, we add 600 to it. No, 17. And that'd be the cost of each one. Okay. Now, it would be possible to get like cents here, like because we're talking about money and how much something costs. But typically, when you see something priced, like a computer, you don't usually see like 99 cents, and in some cases, especially for something big. Like if you go to the store, a lot of times you might see something for like $4.99, right? Because they trying to get you to make it seem like it's a little bit cheaper, and that's where this 99 comes in. Basically, this is $1,200, but $11.99 sounds a little bit better than $1,200, and that would be our two costs. A little bit harder to check this one, but if you really wanted to check it, I could take 16 times this plus 6 times this, and it should equal back to where we were, okay, if you really wanted to check it. All right, let's do one more. This one is number 47. And then I'll go back and do that number 11 from Friday with you to help you out with that one. All right, so 47. This time we're talking about buying some cell phones for people in your department. Motorola phones cost $74.95. Nokia phones cost $49.95. He ordered twice as many Nokias as Motorola phones at a total cost of $1398.80. How many of each did he order? All right, so Motorola's are $74.95. You don't necessarily have to write this information out because I know it's written out, but I think sometimes it's helpful just to kind of organize your information. Nokia's are $49.95. And those two together, we spent a total of $1398.80. Okay, the last one we did said how much did each one cost. We already know how much each one cost. This time we want to know how many of each did we buy. Okay, so on this one we better get an answer that's a nice whole number, because we were talking about how many cell phones did we actually buy. Okay, there's two ways to set this one up. He ordered twice as many Nokias as Motorola's. Okay? So what would be the best way or the best thing to put for X? What do you guys think? Should X equal Motorola or should X equal Nokia? Okay? So if I said X equals Nokia, then what would be an expression for Motorola? Morning. How's it going? Good.
This for you. I think Mr. Scripstein wrote in the wrong spot, so
Oh, okay.
oopsie.
All right. Do I need to go? I might need to change that grade because I don't know if it's updated. So do I need to go change that real quick on here probably?
Maybe, yeah.
Maybe. Oh. Okay. Oh, so. So. He wrote that in there for algebra 2.
Didn't they get scouted? Wait, what are we expecting our own kids? They weren't even 9, they banged all the Carolina's just that bad. TCU's not bad. The max
Okay, thank you. Oh, did I? That's your kid.
Thank you. Have a good day.
You too. Okay, so let's say I bought 10 Nokias. How many Motorola's did I buy? 5, right? So to write an expression for that, if I said X, how would I write an expression for Motorola's? X divided by 2, okay? So we could do that. We could say X divided by 2, or we could say 1/2 X. Okay, so everybody loves fractions, right? Let's just stick with fractions. That's the way to go. Fractions are always, we love them so much, we got to put it into the problem, right? Probably not, right? So let's think about a different way I could write this expression. What else could I have done here? That would maybe be a little bit easier. I think I heard somebody say something. Yeah, perfect. X equals Motorola, and 2X equals Nokia. Okay? If I had to compare these two, would I rather do this one or would I rather do this one? Probably the second one, right? Because we don't have any fractions. A lot cleaner, a lot easier to go through. All right. Now we're going to set up our equation. Motorola's cost $74.95. So we're going to go $74.95 times the number that I buy, which is X. Because we're going to use this here. We're not going to use the fractions. Plus, and then for the Nokias, we're $49.95 times 2X equals the total spent. As we solve this one, do we have to distribute? What do you think, Zach? We distribute in here? We are? What would we distribute? Do we have any plus or minus signs here? No, right? It's just this times this. Is it okay to multiply 49.95 times 2x, even though this one doesn't have an x on it? Can be a little confusing, right? So last week we said, if I did 3 plus 2x, can I add those two together? No, right? That is as far as we can go. But if I did 3 times 2x, can I multiply those two together? You bet, okay? So multiplication is different than addition or subtraction, guys, okay? And so that's where we got to really watch our signs. When can we or when can we not combine things together that aren't alike? Multiplication and division we can. So in this case here, it's okay to multiply 74.95 times x is just simply 74.95x. And then here, we're going to multiply both of those together. So 49.95 times 2x. $49.95 times 2 would be 99.9. And now here's what we talked about, right? Because these both have x's on them, can we combine them together? Yeah. Okay, now we can combine like terms. So now both of these can be put together. And 74.95 plus 99.9, 99.9. So then we're going to take 1398.80 divided by 174.85. What do we get? 8. Okay. So we bought 8 Motorola phones. And then how are we going to get Nokia phones? Just double it, you bet. So we bought 16 Nokias. Just got to go back up here to what our expressions represent. Okay, so I'll give you your assignment here in just a second. Let's go back to, this is one of the problems off of Fridays. This was the very first one, and I told you that it's kind of a doozy. But I'll show you kind of an easy way to go about this one. It kind of goes back to, again, when can we or can we not put things together, okay? So number 11 gave us a formula. The formula is up in the directions, not in the actual problem itself. So B equals P plus P times R times T. Okay, B is going to represent the balance at the end, okay? So if you have like a savings account, P is going to be how much I invested into that savings account. And at the end of 5 years, we're going to add some savings to it, right? And we want to know how much do I have at the end. Okay? So you can make money like on savings accounts, money market accounts. Maybe you have a CD. If you have accounts like that earn some type of interest, right? This would be the formula you would use to figure out how much interest I'd have at the end of so many years based on the rate that I'm getting. So B is your ending balance. Well, in this case, they tell me some of the key pieces of information. After 2 years, the balance is $3,330. So that's where we're ending at. 2 years down the road, this is how much we have in the account. So we know how much we end with. We're trying to figure out P. We don't know P. We do know R. Okay, R is 5.5%. Here's the other trick here. We have to change that to a decimal. So we have to change it to 0.055. when we do interest problems like that. And we have it in there for 2 years. Okay, and I'm going to show you the easy way to do this one. What makes this one look like it's hard is that we have p in 2 different spots. So we're like, how in the heck are we going to solve this if we have the same variable in the same spot? Okay? Well, here's what we're going to do first. What happens if I take 0.055 times 2? How much? 0.055 though. What'd you get, Isaiah? 0.11. Yeah. Okay, 0.11. And think about it this way. If I have 5.5% and I double it, if I double 5.5, that would just be 11. So I'm going to make this 0.11p. Okay, this is assumed to be a 1 right here. So 1p plus 0.11p is 1.11p. And if I take 3330 divided by 1.11, means we would have started with $3,000. So you start with $3,000, and 2 years later you end up with $330 for doing nothing. That's where compound interest is kind of a good deal, right? Make $300 and just let that money sit in the account and make you some money. All right, so for today, page 73, it actually goes to page 75, so 73 to 75. All of the problems that I'm assigning here are going to be very similar to what we did in our notes. So 26 to 32 even, and then 46 in